Hello and welcome to Sunday's edition of Cracking the Cryptic. First up, a quick update on yesterday's video. Mark was indeed having what he described as a bit of fun at my expense. Noted that he did rather suspect the puzzle was difficult, but didn't want to throw me off my mental game by telling me so. We can only be grateful to have such considerate friends. If you haven't checked out the video, it's definitely worth a watch. Not an easy puzzle from Philip Huber, but absolutely an amazing puzzle. Now, a quick reminder about the new extra content that we've released on our Patreon page over the last 48 hours or so. We've got Joka van Veenendaal's latest puzzle hunt. That's available free right now. Lots of you have already been trying it and finishing it, and the comments have been great, so do give it a try. And of course, what we've also got on Patreon for all of our $3 patrons right now is our walkthrough video of the Sudoku puzzle hunt that we released just about a month ago, the Harry Potter themed hunt. We've been overwhelmed by the feedback. It's been really great, and many of you are enjoying the video, which is complete with Mark's blooper. So yeah, have a look at that if that's interesting. Now, today's puzzle, you can see it on screen, very colourful. This is by Osh Tirola. Osh is the Austrian constructor, and he's made something of a métier of constructing Sudoku puzzles built around star battles. Star battle being one of my favourite forms of logic puzzle. And this time he's repeated the trick, but he's added in sandwich Sudoku as well, in a puzzle that one of our testers described as one of the best he's ever seen. So this should be really, really good. Let me tell you the rules. What have we got? We've got normal Sudoku rules apply. In each row, column and 9-cell irregular region, 2 digits must be shaded as stars. These shaded cells cannot touch each other even diagonally. Purple clues give the sum of the digits in the 2 shaded cells in their row or column. Grey set clues give the sum of the digits sandwiched between the stars in their row and column. So that is what we are dealing with. As often from Cracking the Cryptic, a completely new type of puzzle. So do have a go. The way to play, as usual, is to click on the link under the video. With that, let's get cracking. Now, how does one start this puzzle? Okay, well, my eyes are drawn to this row because of the sandwich clue is a 2. So that must be a single 2 between 2 cells that add up to 6 that can't include a 2. Right, so this row consists of a 1-2-5 run or a 5-2-1 run somewhere along it, which of course is very unhelpful, but is probably correct in terms of logic. 29, so that's a I was about to say that's a relatively high sandwich clue, and I suppose it is, but in this form of puzzle we're not dealing with standard sandwich Sudoku, so we can't just say, oh, there's a 1 and a 9 sandwiching some cells, which would have to be a lot of cells if the sandwich crusts were 1 and 9, because here, in fact, the sandwich crusts are 1 and 2, because they have to add up to 3. So in fact, this could just be a 4-cell sandwich total, couldn't it? So we could have a 1 or a 2 here, and then 4 cells being 5, 7, 8, and 9, adding up to 29, and then a 1 or a 2 here. Well, this definitely, I'm going to colour in cells that can't be stars in green. So if this was a 1 or a 2, 4 cells. Right, so if we look down this column, we can do a little bit of elimination, because we know that the sandwich, this 29 sum, must be at least 4 cells. So wherever we put the 1 and the 2, we're always going to be having to take up these 2 cells in the sandwich. So let's fill that in. Right, and we can do a bit of star battle logic off the back of that, because now, oh yeah, there's 1 or 2 things that are popping into my mind now. Now, if we look down this column, we know one of these squares has got to be the star. And therefore, if we were to put a star either here or here, we would eliminate the possibility for there to be a star in any of those positions, because stars can't touch each other diagonally. So this is standard star battle technique, but is useful here. So we can label these squares as green, and look, we know one of those squares must be a star, so we can do exactly the same thing at the bottom. Now, when I looked at this just now, I spotted, look, these humps now can't contain stars. So the stars in this bottom region are all in this shape, so they can't be in this shape. We've got 2 stars in this sort of run of yellow squares, therefore there can be no more stars in the row. Alright, 1 second, let me... 17, look. So 17, the stars are going to have to be an 8 and a 9, so yeah, this square can't be a star, because if we try and put a star here with an 8 or a 9, the other side of this one would have to be a 0, which it can't be. So this square can't be a star. This one could be, because it could be an 8 opposite a 1. And this, the 5 can't be, and the 6 can't be, look. So these 2 are not stars. Now, have we got any other easy wins like that? Not that I can see. In fact, there's really not much to go on here. It doesn't surprise me great. This square can't be a star, because if it was, look at this S-shaped region. We've got to put 2 stars into the S-shaped region. Well, if I make that a star, none of those squares could be a star, and I'd have to put 2 stars in this domino at the top, which is impossible. So this must be green. I was about to say that it doesn't surprise me this puzzle is hard, because Osh's puzzles, in my experience, are always hard. But they are also very, very interesting. Now, so similar thing, I suppose. Oh yeah, in fact, nice. This square also would rule out too many squares in the S region. We'd have to put 2 stars into this little region here. Now, you can only ever put a maximum of 1 star in any 2x2 region because of this diagonal constraint. So again, we can't try putting a star here. It would rule a star out of all those positions, and look, we'd have a massive problem in the S region. So we can say with certainty this is green. Now look, this column now, we know that this shape must have 2 stars in it. They must both be in column 9. So we can't put a 3rd star in column 9. This square becomes green. I've got this horrible feeling that I'm not doing this puzzle in the intended way at all. But there's nothing else we can do. We've only got 1 given digit. Oh, so if we look at this column, we've got 3 sandwiching a 29 sum. So 29 plus 3 is 32. So I know that the total for the whole column will be 45, because that's what we get when we add up all the numbers from 1 to 9. So the cells outside the sandwich here, outside wherever I put the 1 and the 2, if I put the 1 and the 2 in these 2 positions, for example, the cells outside would have to add up to 13. And the way we can do that is just, we know these 2 yellow squares add to 3, we know that inside of the sandwich adds to 29, so these 3 squares, in order to make sure the column adds to 45, would have to be 13. Including a 6. So we're either going to have a single 7 in one of these 2 squares, or we're going to have 2 cells that sum to 7. Oh, this is no good. This is not the way to crack this puzzle. Oh, bobbins. Look, there's something really obvious that I've not done. And that is to note that if we think about the sum of the stars in the rows, self-evidently that must equal the sum of the stars in the columns. So I'm now going to add these up and see what I get. So I'm going to get 39, 48, 53, 62, 68. So this is 68 on the right hand side. 68, let me just try and remember that. So we've got 38, 51, 57, 71, oh, we've got 82. 82 versus 68. 14 is the difference. Ah, yeah, okay. So this is huge. Ah, I should have done this at the start. This is hugely important. So the difference between the purple squares in the rows, the listed purple squares in the rows, and the listed purple squares in the columns is 14. Now, how can we put digits into these two positions such that we eliminate that difference? Because we must eliminate it. We know that once we populate the grid with stars, the stars for the columns and rows are going to have to be equal. Well, the maximum difference I can create would be a 3, i.e. a 1 and a 2 in this column, versus a 17 in this row. 17 minus 3, which is the biggest difference I could create, an 8 and a 9 in this row, a 1 and a 2 in this column, the difference is 14. So this, I can't actually annotate it. If I remember, I will add it when I edit this video, but this purple clue here is a 3, and this purple clue here is a 17. Now, if this is a 17, this square can't be a star because we know the 17 will be made up of an 8 and a 9. This can't be a star because we can't pair 8 with 0. This can't be a star because this is a 3 clue, so the stars in this column are 1 and 2. So we get 3 extra stars in row 1. And do we get anything extra? Sorry about this, let me just think. This is a 3 clue. No, I can't think of it, but I've noticed this square. This square can't be a star, because if it's a star, it rules a star out of those 3 squares, and I'd be left with trying to put 2 squares or 2 stars in a 2 by 2 block. That's not possible. Oh no, I thought for a minute that couldn't be a star, but I think it can, because I can put 2 stars in this row, look, in these 2 positions. So, This is really tricky. I'm so sorry if you're seeing a quick way of doing this. I certainly am not. Okay, so let's think about this. Sorry. Look, this square can't be a star, can it? Because this is pairing a 14 clue with a 5 clue. So I can't put a 5 into this square because then its paired star here would be a 0. The maximum this could, if this was a star, the maximum it could be from the row's perspective is a 4, and that would make the column impossible. So this is green. So now, now here's something else. Look, the T region here, we know that there must be a star in one of these 3 squares. So there must be, I'm going to label that blue. There's 1 star in this 3. There's 1 star in this 3. Therefore, in the T region, there's exactly 1 star in these 2 squares. There can't be 2 stars up here because that would mean we wouldn't be able to put a star in the blue region here, and that would break the 29 clue. So if there's 1 star here, there is exactly 1 star here because there must be 2 stars in row 1. So this domino contains a star, and therefore we can make this square green because we can't, if we've made this square a star, it would obviously rule out a star from both of those squares. Okay, is this helpful? Well, it might be, but it's not very obvious how. So now I've got to be a little bit careful with this. I couldn't have 2 stars there, for example, because that would break this C region, because I couldn't then put a star in any of those yellow squares. How do we... maybe we can use geometry. Can we use geometry of the grid? Yeah, maybe. Let's look at the first 4 rows. In the first 4 rows, there are 3 complete regions. So those 3 complete regions will contribute 6 stars exactly. Now that means, in order to ensure there are 8 stars exactly in the first 4 rows, this region has got to contain exactly 2 stars. This region here, this 3x3 region, has exactly 2 stars in it. Okay. So is that... now that is interesting, look. That is interesting. Right, there's a few things we can notice here. Let's have a look at column 9. Let's imagine there were no stars in this region, in this 3x3 and this 1x3 region here. Now if that's the case, we know there must be 2 stars in this 4-cell region. But if that's the case, we can split that into 2 dominoes. There couldn't be any stars in that region. If there were 2 stars in here, let's put them in. It doesn't matter how we put them in. The key point to realise is it rules star out of all 4 of those squares. And now there is not enough room in column 8 to place 2 stars. So we know that there must be at least 1 star. Yeah, this is nice. There must be at least 1 star in this yellow region, but there can't be 2, look, because if I try and put 2 stars in this yellow region, like this clue's broken. I need these 2 squares to add up to 11. Well, they can't add up to 11, because the maximum I could put in this square is a 5, and the maximum I can put in that square is a 4. So there is exactly 1 star in this region, and therefore there's exactly 1 star in this region, because we know that the 3x3 here contains 2 stars exactly. So there's exactly 1 star in this region. There's exactly 1 star in this region because of the S. I know I need to put 2 stars in the S. 1, 2. Nearly. So close to locking in the positions of the stars in columns 7 and 8, where I know there must be 4 stars altogether, and I've located roughly 2 of them. This is really, really interesting. I've had 18 minutes. I've not, I mean, this must be a record. I've not even got a pencil mark in the grid. Not 1 single pencil mark. I've got to remedy that. How can I put a pencil mark in the grid? Oh dear. Okay. So maybe I have to somehow use this 2 clue then. Because we know the 2 clue is a run of 3 cells. It's either 1, 2, 5 or 5, 2, 1. Yeah, okay. I think I can see it's not possible that this square is a star. Because if this square is a star, because it's got to be either 1, 2, 5 or 5, 2, 1, this is a star. And this surely... So now you can see that in the T region, where do I put my 2 stars? They're going to have to be in those 2 positions. And that breaks the fact that I need to put a star in one of these 3 orange stars. Orange cells. I can't do that. So this is not a star. Ah, that's interesting now. Right, let's look at row 2. Oh. Okay, well, I've noticed something interesting. In row 2, we have a run of 3 cells and another run of 3 cells. So if row 2 was arranged in such a way that there was 1 star in these 3 squares and 1 star in these 3 squares, if that was the orientation for row 2, then we wouldn't be able to put a star in this position, because that would rule out all 3 of those, and we wouldn't be able to put a star in this position, because that would rule out these 3. If there is no star in those 2 positions, you break the T-box, because there is only 1 star possible in these 3 squares. So we actually know, looking at row 2, that it's not the case that there is 1 star in this run of 3 and 1 star in this run of 3. So in one of these 3 runs of 3 cells, there is no stars, and in one of them there is 2 stars. Now that must be... I might be able to visualize this. Let me just have a stare at this and think about it. So if we're trying to put 2 stars into one of these runs of 3, 2, that, yeah, okay. This is good. This is good. We have got somewhere. Right. So let's work out which of these runs of 3 squares contains the 2 stars. Let's try and put the 2 stars in this run of 3, like that. Now this breaks. Now the reason it breaks is, let's think about the T region now. How are we going to put our 2 stars in the T region? They've got to go in those squares. They're the only ones available once we try 2 stars in this configuration. Now, look at the 9-shaped region, or the Q region, depending. Where are we going to put our 2 stars in this region? They've got to go in there. And right at the very start of the puzzle, I noticed we couldn't have 2 stars here because this breaks the C-shaped region. We now can't put 2 stars in the C-shaped region. So it's not possible for there to be 2 stars in these 2 squares. Therefore, this must be the run of 3 with no stars in it. How huge is this? Once there are no stars in there, this is a star. And that means this is a star, and now this is a star. And finally, I think I might be able... I don't want to speak too soon. Let me just surround these stars with green. I might be able to put a digit in the grid. Maybe. This has got to be a star. There must be 2 stars in row 2. And we knew that it was either this run of 3 or this run of 3 that contained the 2 stars. We now know it's this run of 3. Oh no. I can put pencil mark. I can put a 2 in. I can put a 2 in. There's a 2. That is definitely a 2. And these must be 1 and 5. Let's surround that one with green. Row 3 now. Look. Where do the stars go? Well, there must be 1 in this little domino here, and this must be a star. So that gives us a little breakthrough. Okay. Well, actually now look down this column. We know that the stars in column 6 add up to 3, so they can't possibly include a 5, so I get a few more digits in the grid. And we know that in column 6, the cells outside the sandwich sum to 13, so deduct 6 from 13, 7. So we know this square can't be a star, because if it was, we wouldn't have 13 outside the sandwich. So that square's green. That gives us a domino in the M-shaped region. Those 2 squares turn green. We've also got, look, a domino there, so that must turn green. Okay. Let me just have another stare now to see if I can work out something else. Oh no, I was about to say this has to be a star, but I don't think it does. Good grief. I mean, how clever is this puzzle? It's still... I've not even got anywhere near the irregular Sudoku part of it yet. So there's got to be... Oh, I'll tell you what might be... Yes, look at this square. If this square here is a star, there's a 2. Oh no, that would... Yeah, no, this works, this works. If this square is a star, where do I put the 2? I can't put it here, because then this square would have to be a star in order to ensure that the sandwich filling was 2, and we know this square is green, it's not a star. So I'd have to put the star here, and this square would be a 2, and that clashes. So that doesn't work. There's just no way this square can be a star, and therefore this square is a star, and that gives us a bit more to go on. It means this square is a 2, because we know the stars add up to... Therefore, this square is a 2. Sorry, not a 2, but it's a star because we need 2 stars in column 7. We know that these two are a 1-2 pair. Ah, look, and we've got an 11 here in this one. So we can't put a 1 here. The other star would have to be a 10. We can get rid of that one. Oh, this is so good. I feel like I'm finally making some progress. Need 2 stars in this column. Get rid of those. Oh, we've got a 2 here and a star here. So this has got to be a 6. 14, so that's got to be an 8. Oh, and we have got a 17 clue here, haven't we? So one of these 2 squares must be a 9. What the star in this domino is a 9. Now that means it's probably here, but we don't know that for sure. In this region, we've got a sort of triple there that must contain a star, and one of those squares must be a star as well, because we know we need 2 stars in this sort of, I don't know, water pistol shaped region. Oh, have I got my 2 stars in the M region? I think I have. So this must not... There's no stars there. Oh, now I need 2 stars in row 7. So they've got to be in those 2 positions. That's the only place I can put them. Let's ring those off. This must be a 2, therefore. This can't be a star because it's diagonally adjacent to this star. Now I need 2 stars in this column, so again those 2 squares are forced to be stars. But I don't know... I do know what they add up to because I can use the rows. Look, that must be a 4. That should be a 9. It does work, thank goodness. That's green. This is a star to complete the second star in column 4. So that's not a star. There must be a star in this domino to complete column 3, so that's not a star. Let's shade those in. There's a star in one of those 2 squares. Oh, okay, so we can rule a star out, look, from these 2 positions, because we've already locked in 4 stars in columns 1 and 2, so we can't have a 5th star. We've got 2 in this row, so that's not a star. This becomes a star. This must be a star to complete this row. We've got 2 stars in the Q-shaped region. So this is green, this is a star. That's 2 stars in column 1. And finally, I think that is the configuration of stars. Wow, half an hour. I'm sorry, I did my best, I really did. 9, 8, therefore, like this. Now I've got to do irregular Sudoku as well as put some numbers into these stars. So let's try and do that. This has got to be a 3, look, because of the 11 clue. That's still working with the 8. That's good. So which of these is restricted then? One of them. These have to add up to 11. There's quite a lot of license though when they've got 9s in the rows. This has got to add up to 13. 7 here. Maybe that's easier. Is 7 here important? I'm not sure that is. But I suppose if these are the stars, this must be a 7. Because it's the sandwich filling. This column now, we need a 7 here, don't we, of course? Sorry about this. I am well aware that I'm not... I've got a 21 sandwich total here. And then 9 fillings. So these two squares add to 9. 9 plus 21 is 30. These two squares have got to add up to 15. They've got to be 6, 7, 8, and 9. This can't be 8 or 9, so this can't be 6 or 7. Okay. So what is it I'm missing about? "13" could be 5, 8, 6, 7, or 4, 9. Nine is tricky though, isn't it? 9 could be ruled out of both positions because of the 9s in the rows. So this is not 4, 9. This is either 5, 8 or 6, 7. Oh, this one. It's because I haven't put this one in. This is 3. So this has got to be 1, that's got to be 2, and that's going to finish them. 8, 5, 4, and 7. And they're all done. The 7 here, look, fixes that this has got to be a 6 and a 9 to make 15. And all of a sudden, I think... So now, I've used... no, I've not put the 4 in there. That's a 4 from this clue. So now, with all the stars placed and all of the sandwich totals used, this is now it's just irregular Sudoku from here on out. Right, 1s and 4s. Look, we've got 1s and 4s here. These two 1s and 4s and these two 1s and 4s on the C-shaped region. So that locks a 1-4 pair here, look. And you can see there's a 1 there. So we get a 1 and a 4. Now this C region. Same thing, 1s and 4s. Where do they go? They must go in those two squares. Which, rather irritatingly, I can't see how to resolve. So these squares now have got to be 3, 5, and is it 7 that's missing? 5 up here is certainly missing. So 5 goes there, 7 goes here, 3 goes here. Now, is that right? I think it is. So now in this column, we need to place 2 and 6. Can't see how to resolve that. Now, what next? 2. Yeah, where does 2 go in this funny region at the bottom? 2 can't go in either of these dominoes, so it must hide in the corner. 2, 6. 6 must be in one of those two squares because of this 6 ruling it out of the top of the sort of wrench-shaped region. Now, let's have a look at this square, perhaps. There must be an 8 in one of those squares because of this 8. There can't be a 2 here either. And there can't be a 2 there, so this must be the 2. It's the only place a 2 can go in this C shape. 7. Where does 7 go in this C shape? It must go there. That means that's an 8 and this is a 3. These two squares are 6 and 9. 4, 5. No. Okay. Maybe, can we do anything with 1? I'm not sure. These two ones, what are they doing? Maybe this row. 3, 5 and 9 into those squares. Let's have a look at that. That is hopeless. Bobbins. There's some geometry, look, we can do. This square and that square have to be the same, because we know in this column, basically whatever I put into this square must also complete this region. So these two squares are the same. Now you can see that does give us a bit of a restriction because of the options for this square and the 4, 7. So in fact this has to be a 2 or a 5. That's lovely. So this has to be a 2 or a 5, just comparing the contents of those squares. Now once we get that, that 5 here forces a 5 into the top of the grid. That gives us a 2. This can't be a 5 now, because that's part of this region, isn't it? So there's and this can't be a 5. So this 5 is really amazing. It rules a 5 out of both of those squares and plonks a 5 into the S-shaped region. This is the mad thing that you get with irregular Sudoku. Now, this 5 is interesting for the wrench-shaped region. Where does the 5 go? It must join the 6. That means those two squares have got to be 1 and 9, which we can place. So 1 and 9 go here. Now let's do the geometry. If we know that there hasn't been a 1 and a 9 yet in this row, we can just label these two squares 1 and 9. This one... No. This one fixes the 4 there, which fixes the 1 above it. Remembering that the 1 and the 4 are both in this funny C-shaped region. Now, we need 3 and 8. Now, this 3 is important. 3 and 8 go in like that. The 3 here fixes the 9 here. That fixes the 3 here. That fixes the 1 and the 9. Oh, and I've not put a 1, look, in this column yet. So it can't go there. It can't go in the S-shaped region, so it must go here. Oh no, I've broken the puzzle. I don't believe it. What have I done wrong? Oh dear. What have I done wrong? That is a bad error. Let's just go back slightly and have a look. So this 3 gave me a 9 here. That looks reasonable unless I've made a mistake a lot earlier. This 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This 9 forces this to be a 9. That would seem to force this to be a 1. This 1 here seems to tally with my 1 there. But I definitely have not put a 1 in this column, have I? And the 1 can't go here, it can't go here, it can't go here because of this 1 ruling the roost over everything. And it can't go there. Oh no. Oh no, what have I done wrong? Oh, this is so depressing. I desperately want this video to appear because this puzzle is so brilliant. But I've clearly done something wrong. I think I'm going to just unwind a little bit and have another stare and see if I can spot my mistake. So maybe this 6, no, that 6 is locking things in there. The 5s, this 5 would seem, unless I've made an absolutely catastrophic scanning error, which is very possible. These two squares have to be a 5-6 pair. To complete the wrench-shaped region, I do need 1 and 9. That's forced to be this way round according to what I've got in the grid. That does force the 4 and the 1 there and there. This square being a 2, maybe if I could put the 1 there, that would be better. So maybe it's this 2 that's incorrect. That's believable, isn't it? So this is a 1-9 pair, if I haven't made another error. What gave me this 2 in this position? Oh, why is that a 2? I thought I made that a 5. This has to be the same as that, doesn't it? What on earth am I doing? Ah! I'm going completely bananas. What did I... Oh, well, at least this is the error. This is for sure the error. Once this... Oh, I know what I did. I'm so sorry. That is a 2. That is a 2. Now this 5 now doesn't rule the roost over those squares after all. Oh my goodness, you must all think I'm a complete imbecile after the last 5 minutes of this video, but I think I've resurrected, or at least I found the error. Right, let's start again. No, not literally. Not literally. We can come down here, we can place 5 and 6, we can place 1 and 9, we can do the 1, do the 9, do the 4, oh, do the 4, do the 1. I've still got this issue now with where does the 1 go in this column. 1, 9 here and here. These two squares have got to be 3 and 8. The 3 here fixes the 3 on this side, that fixes the 8 on this side. Oh, this is better though. This is better because before I had to put the 9 here because I'd eliminated a 5 from this position. So okay, we are on a different track. Thank goodness. Right. Okay. So where do we look for an easy win here? That is the question. And you'll forgive me if I take my time over this. I do not want to mess this up again. 5 here, plonks a 5 there. We haven't put a 5. This must be a 1-3 pair to complete this column. I think we must have done almost all the 1s now. I feel like I've done a lot of 1ing. Ah, that's got to be a 1 in this row. That's... Yes, it does. That fixes the 1 and the 9 in a different order. That gives me a 5 here, which was never possible before. So now I have done all the 1s. Let's have a look at those two squares, look. They've got to be 6 and 8, which is resolved by the 8 over on this side. So 8 and 6 go in. Oh, we can use some geometry here. We can use some geometry. Let's imagine the grid was divided by a line that came across like this. Now, if you look carefully, you can see that these 4 squares here and these 4 squares have got to contain the same digits. Now, how do we know that? Well, it's because we know that the first 4 rows of the grid will contain all of the numbers from 1 to 9 4 times exactly. Well, we've got 3 complete regions, so that caters for 3 of those 1 to 9s, and that means that this set here must contain the digits 1 to 9 as well. But so must this region. So whatever I put in here must also therefore appear in here, and these squares have got to be 4, 5 and 8, and there's a 5 here, so this is a 5 by geometry. This is a 4-8 pair, there's an 8 at the top. 8, 4 go into the grid. That forces that to be a 6. So if we scan down this column now, we need 3, 7 and 9. That's got to be a 7 or a 9, I think. 3, 7, 9 here. 3, 4, 8 into these squares. Is that resolved yet? I feel like it probably is. I'm just not quite spotting how. 3, 4, 8. No, don't know. The 6, 9 here combined with the rest of this column, look, means this is a 7, 8 pair. So that's an 8, that's a 7. This 8 fixes the 3, 4 and 8 along there. Five, 6, 7 up here. So this is 5 or 7. And this is 5 or 7. So that would imply this is the 6. This is a 5. This square here has got to be 6 or 7 just to complete the row. And come on, let's finish this off now. This column, I suppose. It needs 4 and 9, which we can place because of the 9 here. This must be 5 or 7, which is also resolved by the 5 at the bottom. Oh, 3 9s into these squares. You can see 3, 9, 3. Don't mess this up, Simon. And that should be a 4. It looks plausible. This looks plausible. Yes. So I almost had a complete ricket in the middle of that, and I'm really sorry about it. It was just the way I saw this 5, knew that was a 2, and then for some reason, having said these had to be the same digit, made them not the right digit. But what a wonderful puzzle that is. That is not easy either. I'd be very interested to hear in the comments how long it takes you guys to solve. As you can see, it's taken me rather a long time. Anyway, thanks for watching. We'll be back later with another edition of Cracking the Cryptic.